Hello guys, welcome back. We are starting the second half of Unit 4 with 4.5. 4.5 we start looking at, and 4.6, we start looking at the graphs of our trig functions. And so how can we graph this using what we know about the unit circle? So we have 4 objectives today. The first one is to sketch the graphs of basic sine and cosine functions. So we're going to look at the unit circle and try to come up with some points here. Then we're going to use amplitude and period to sketch the graphs of sine and cosine functions. So amplitude is how far, like up and down, it goes. And then period is how long does it take to go from start to finish. Then we're going to sketch translations of graphs and of sine and cosine, so translations. So once we know how to graph the parent graph, what does it look like if we move it left or right or up and down? And then the last one is we're going to use sine and cosine to model real life data. So we're going to look at how does that work. Okay, so let's scroll down here and let's look at our sine curve first, okay? And I'm going to go ahead and forewarn you, when I am drawing this in person, I do a very good job of drawing these, but I have a feeling that with my little drawing pad here, this is not going to go as well. So just have a little patience here. Okay, so what we're going to do is we're going to complete this table, and then we're just going to plot those points. So we need to think about the unit circle. Remember that sine are your y values, right? So at 0 radians, so I'm just going to quickly draw, our unit circle. Something like that. At 0 radians right here, this is the point 1, 0. So at 0 radians, the sine, the y value is 0. At pi over 4, which is here, right? I have square root of 2, comma square root of 2. So the y value is square root of 2 over 2, which is about 0.7-ish. Just so that even though it says exact, I kind of like to know what it is in decimal so I know how to graph it. Pi over 2 is right here at 90, and this is the point 0, 1. So my y value is 1. At pi, again, it's negative 1, 0. So my y value is 0. At 3 pi over 2, it's negative 1, 0. So my y value is, it's 0, negative 1. 0, negative 1. There we go. So it's negative 1. And then at 2 pi, again, it goes back to 0. So what we're going to do is we're just going to plot these points. So at 0, 0, 0 is a point. This is the trick. This is what I do every single time. I'm going to make 4 tick marks, and I'm going to space them every other. So 1, 2, 3, 4. And this is going to be my rotation around the unit circle. So 0, and then a quarter of the way around is pi over 2, which my output is 1. So let's just call this 1, right? My output is 1. At pi over, it's here. Holy moly, right? So a quarter of the way around the unit circle, I have an output of 1. Halfway around the unit circle is where pi is. I have an output of 0. 3/4 of the way around is 3 pi over 2. So that gets me negative 1. And then I'm back to 0. And then a quarter of the way is like around like 0.7-ish, so like here. We can call this negative 1. So what happens, told you guys, this is not going to be pretty. What happens is as I connect these, it makes this curve. Okay, that was like actually a lot better than I thought it was going to be. It makes this curve. okay? And I'm sure you guys have seen sine waves before. And this is one period. And we said in the last lesson that one period for sine is 2 pi. So it takes 2 pi, and I'll label this one, right? All the way around is 2 pi. It goes from 0 to 2 pi is all the way around the circle. And that's all it's saying. My dog's gonna. Okay, so, and then what happens is I can just keep repeating this. So I can draw 4 tick marks. And then now this would be 4 pi, right? Twice around the unit circle. And it would just keep going. And so I can draw my points and just connect it. Ooh, that one wasn't as good. Alrighty. Just like this, or I can keep going this way. Right? And so it would be down. And so this would be negative 2 pi. And this would be negative pi. And this continues on forever. So you guys get the picture, okay? Normally, I will fill out my graph paper. And this is called Trig graph paper, and I will give you some of this. So if you want, I mean, I guess you don't have to, but it is kind of helpful to have that. So this goes on forever in both directions. You can see why now the domain of sine is all real numbers, right? Because it goes from negative infinity to infinity. And then why the range of this is -1 to 1. So this is our parent graph of our sine. Let's look at cosine now. So let's scroll down. For cosine, again, we can draw our unit circle, just kind of as a reference. Remember, cosine are my x values. So right here at 0, my x value is 1. At pi over 4, again, it's root 2 over 2. At pi over 2, right, this is 0, 1. So the x coordinate is 0. At pi, I get -1. At 3 pi over 2, I get 0. And then at 2 pi, I get 1 again. So very, very similar. I'm going to draw my 4 tick marks. And I like to space them out every other. And I can call this 2 pi. This is pi. Only this time my points are a little different because I'm starting at 1. So I start at 1. Then I have like that 0.7-ish, right? Then 0. Then -1. Then 0. Then 1. So while the curve, more or less it's more or less the same points and more or less looks the same as sine, the only difference is that it's starting at 1 instead of 0. And again, you can keep going. And I would encourage you. I normally like to, like I said, fill out the entire graph. And you don't want these to be V's, okay? It should be a smooth, continuous curve. It's not like a sharp V. So just keep that in mind when you're graphing them. Notice that at no point does it make a sharp turn. So just kind of keep that in mind when you're drawing it. Something like that, where this would be 4 pi, and here's -2 pi. So again, here you can see why the domain of cosine is all real numbers, and you can see why the range of cosine is -1 to 1, same as sine. So right here, like I just said, the domain is that x is in the set of all real numbers. You also could write -infinity to infinity. It's just not as like mathematically professional or whatever you want to say. Range, I go from -1 to 1. Amplitude. So amplitude is the height, but I want to make a note of this. It's actually half the height. So what it is the amplitude is the height from equilibrium, right? So equilibrium is that line that goes right through the middle. In this case, equilibrium is the x-axis, right? So then it's the height from the x-axis. So you can also think of it as like 1/2 the maximum value minus the minimum value. So like if we have moved this graph up or something, it might be a little bit harder to figure out what the amplitude is. In this case, the amplitude is just 1, right? So the distance from x-axis up is 1, the highest distance. The next thing that's on your paper, and it's right down here, and I know I didn't fit it, and that was my bad, is the period, okay? That's the width of one cycle. So width of one cycle. So both sine and cosine, the period there is 2 pi. I'm probably going to have to just clear this here. I'll rewrite it. So the width of one cycle. So the period here is 2 pi. And then the last one is symmetry. And these have different symmetries depending on which graph you're looking at. So for sine has rotational symmetry. Around the origin. And if we think back, of course I can't fit it. If we think back to first semester, anything that has rotational symmetry around the origin is an odd function. So sine here is an odd function, which we actually talked about last lesson in 4.4. And then cosine has reflectional symmetry, right, on the y-axis. You can just fold it along that y-axis and it'll be symmetric. And by definition, that means that it's an even function, which again, we talked about last lesson. So just a couple characteristics for us to know. What we're going to look at now is what happens when the amplitude is different. What happens if the period is different? What if it takes longer than 2 pi to go all the way around the circle? Stuff like that. So we're going to look at amplitudes and periods and how they affect our graph. Okay, so here are my parent graphs. Y equals d plus a sine or cosine of bx minus c. So I could have a number here, I could have a number here, b or c. There's lots of different options, okay? The amplitude is always going to be the absolute value of a. That's it. The period here, this one is really important. Okay, because the original period of sine and cosine is 2 pi, that's where this comes from. Okay, so that's the original period, which is 2 pi, and you're going to divide it by the absolute value of whatever b is. B is the number in front of x. Okay, phase shift. Okay, what a phase shift does is it's your horizontal shift. Okay, so I can say horizontal shift. And this is really what I like to do here. I like to set, you can do C over B, but then you have to know to move it over that much. Or you can set this whole parenthesis, bx minus c, equal to 0 and equal to 2 pi, because 0 is the starting point for your parent graph, and 2 pi is the ending point for your parent graph for both sine and cosine. So this personally is what I like to do, because if I've moved it over pi over 3, let's say, then I have to do the fraction calculation of figuring out what those new points are. Versus if I do it this way, I'm automatically given what my new points are, so I can label them on the graph. And then as normal, whatever you add or subtract is your vertical shift. So just how far up or down it's moved. So we're going to look at these, and I'm going to use a couple colors here. So you might want to have maybe a couple different colors, at least 2, If not, just make sure that you're really good at labeling, okay? So the first part says determine the amplitude of y equals 2 sine of x. Well, the amplitude is always my a, so right here. So in this case, my amplitude is 2. So what that means is from equilibrium, it's going to go up 2 and down 2 instead of 1. Then graph y equals sine of x on the interval negative pi to 4 pi. Okay, so I'm going to start with my parent graph. And it's sine. So sine starts at 0. Now normally it would go up to 1, right? But in this case, we're going up to 2 because my amplitude is now 2. Then 0, then negative 2, then 0. So as I go to draw this, there we go. And this is 2 pi, right? And then here's pi. I don't know why my marker doesn't want to write pi. It wants me to go to 4 pi, so I need to do another one of these, right? Where it goes up. I usually just draw the points. It gives me like a good target for when I'm trying to draw, because I like to make these look really neat and pretty. So here's 4 pi, and here's 3 pi. And it wants me to go to negative pi, which is right here. It doesn't want me to go all the way to 2 pi, or negative 2 pi, excuse me. So there it is, something like that. It says use a graphing calculator to confirm your answer. We can definitely do that. I'm not going to do it, but I would love if you did. Then it says also graph negative 2 sine of x. Well, the negative here, what color do we want to use with blue? Use this orange. The negative here, just as it was with a parabola or exponential or logs or anything that we've done already, this is an x-axis reflection. So this just means that all my points are going to flip over the x-axis. So 0, 0 is still going to stay there, right? But this one's going to go up. So all the ones at 0, oops, I'm not thinking. All the ones at 0 are going to stay. But all the ones that are at 2 or negative 2 are just going to flip over the x-axis. So apparently I cannot talk and draw this at the same time. But I'm doing an okay job. And there it is. So this guy right here, the orange one, this is my y is equal to negative 2 sine of x. Okay, whereas this blue one is y is equal to 2 sine of x. So the negative there, all it does is it flips over the x-axis. Okay. Example 2 here. Hopefully that makes sense. Again, always reach out if you have any questions. Example 2, very, very similar. The only difference is it's cosine. I want you guys to go ahead and try this, either using different colors or just make sure that you label it very carefully. I want you to try this. Notice the only thing that's different is the amplitude, and it tells you what it is, right? So here we can do this part. My amplitude is 1/2. And then over here, my amplitude is 3, and you're just going to sketch them both. So go ahead and hit pause on the video, try it, and then when you're ready to check your work, hit play. Okay, so here we have those two graphs on the same coordinate axes. So my orange one here is B, which is 3 cosine of x, right? The amplitude is 3, so that means it's going to start at 3. Because remember that cosine starts at 1, 0. right? And then with an amplitude of 3, it brings you up to 3. So it starts at 3, and it goes down to -3 and then back up, and it just repeats. Same thing with the amplitude of 1/2. Normally it would start at 1, but because of that amplitude of 1/2, it starts at 1/2 and then goes down to -1/2, and then positive, negative, and so on. So hopefully that makes sense. Again, as always, reach out, let me know. Please, please, please. Okay, so that's amplitude. We're going to move on now to horizontal stretching, which just means making, so like you have a sine wave, right? Making it stretch out longer. Like if you had actually wire that was shaped like a sine or cosine wave and you pulled it out and made it just take up more space. So make the period longer is what we're looking at here. So horizontal stretching. So here, I have this equation. The biggest thing that throws people off here is they're like, what the heck is this? Like, what's the number in front of x? Remember that this is the same thing as y equals sine of 1/2 x. So these two things are the same. So just because the x is on top doesn't mean that there's no number in front of x. Okay, you still have this 1/2 as the coefficient. So I like to make a little list when I'm graphing so I know all of the information that I need. So my amplitude here, the number in front of sine, is just a 1. So it has not gotten taller or shorter. The period, right? Normally the period is 2 pi, so we have a 2 pi on top. And then whatever is the number, the coefficient of x goes on the bottom. So in this case, that's 1/2. Okay, so 2 pi over 1/2, I'm actually going to write the equation first because I think maybe that'll help. So the formula that we had on the previous page was 2 pi over b. And so in this case, b, the number in front of x, is 1/2. 2 pi divided by 1/2 is 4 pi. Okay, so what this means, it's not going to change the way I graph. The only thing it's going to change, I'm going to write my 4 tick marks. The only thing it's going to change is instead of the fourth tick mark being 2 pi, now it's going to be 4 pi. That's literally the only difference, okay? And then just for the sake of consistency, there is no phase shift here because there is no plus or minus inside the sine function. And there is no vertical shift because there is no plus or minus outside the sine function. So now I'm ready to graph it, right? Sine wave starts at 0, and it goes to 1, and then it goes back to 0, and then it goes to -1, and then it goes back to 0. So here is my sine wave. And then halfway, right, between 4 pi will be 2 pi. So the only difference is instead of taking 2 pi to go all the way around, now it takes 4 pi to go all the way around. And then I can continue this just keeping in mind the new period. Right now the period is 4 pi instead of 2 pi. Oops. So I can keep going. Like I said, unless it specifically says to only graph one period, I tend to like to graph the whole thing. Sometimes I will only label the one period, the first period. Sometimes I'll label all of it. It just, it's really up to you. Okay, let's try another one, shall we? So let's look at A here. It says determine the amplitude and the period of y equals -4 cosine pi x, then graph the function from -2 to 2. So my amplitude is 4. Remember, your amplitude is always the absolute value of that number, okay? The negative tells me that there's an x-axis reflection. So we're going to have to know what the parent graph of cosine looks like and then reflect those points over the x-axis. Okay, then the period, remember the period is always the original period, which is 2 pi, divided by b, which is the number in front of x. So in this case, I have 2 pi divided by, and the number in front of x is pi. So the pi's cancel, and I just get 2. So that tells me that, let's do our phase shift, sorry. So my phase shift, there is none. There's no plus or minus inside the cosine. And then my vertical shift is none. There's no plus or minus outside the cosine. Okay, so because my period now is 2, again, I'm going to draw those 4 tick marks. So basically graphing it's the same every time. I'm just labeling this different. I'm just going to label it 2, which is fine because it wants me to go to 2. Okay. Now I have to ask myself, where does cosine start? Cosine starts at 1, but it has an amplitude of 4. So really it's going to start at 4. But then it also has an x-axis reflection. So it's going to start down here at -4. Okay, so hopefully that makes sense. 0 is going to stay the same. Okay, normally the cosine point here would be -1, but it has an amplitude of 4, so it'd be down at -4. And then it has an x-axis reflection, so it's up here. And then I'm going to continue the pattern. And I'm going to connect it. So in this case, it looks like a sine wave or a cosine wave. It's just reflected over the x-axis. And it wants me to go from -2 to 2. So I'm going to have to also do 1 whole period to the left as well. But once you've done the first one, it's just continuing the pattern. And so it shouldn't be anything hopefully too crazy. My drawings are slowly getting worse, you guys. And there is my graph. Okay, are we feeling all right? Sine and cosine still so far? Okay, so that's horizontal stretching. That's changing the period. Okay, so again, instead of being 2 pi, it's just 2. So I'm just changing the period, but I'm graphing it exactly the same. And that's the biggest like cheat sheet that I can give you, or like tip that I can give you, is I just always graph it the same. I just label it what I need to label it as. Okay, so now we're going to move on to our translations. So we're going to look at, I have my sine wave, but it's been moved. Does that make sense? So I've moved it left or right or whatever. So it says use a graphing utility to analyze the graph. We're not going to do it with a graphing calculator. We're going to do this by hand, okay? So we're going to make that list and write down all the information we know. So here I know that my amplitude is 3. I also know that there's an x-axis reflection, right? Because of this negative. Then the period, it's always 2 pi divided by whatever's in front of x. In this case, what's in front of x is 2 pi. So the period is 1. And that's okay, right? That means I'm going to draw my 4 tick marks and have it be a 1. Vertical, there is no vertical shift here because there's no like +7 or whatever outside. So because there's nothing on the outside, there is no vertical shift here. And then because of this right here, there is a phase shift. And the phase shift is just your horizontal shift, okay? And then, like I said, there was multiple ways that you could do it. We looked at that formula on the previous page. That was C divided by B. But honestly, I think it's easier to just set the entire parentheses. So 2 pi x plus 4 pi. Oops, I almost wrote x. I'm going to set it equal to the original parent graph starting point. Well, the starting point for cosine is 0, right? Here's the parent graph right here, right? It starts at 0. Then I'm going to take what's inside the parentheses, and I'm going to set it equal to the original end of the period for the parent graph, which was 2 pi. I'm going to get rid of this now because I don't want it to throw us off. Okay, so the original start of the period is 0, and the original end of the period is 2 pi. Now I'm going to solve for x. So subtract 4 pi. I get 2 pi x is equal to negative 4 pi. Divide by 2 pi. Divide by 2 pi. And I get x is equal to negative 2. So this tells me that's where I'm going to start. I'm going to start at negative 2. Okay. And so I'm just going to go ahead and draw 1, 2. If I do every other one, I won't be able to fit negative 2 on here. So I'm going to have to do every tick mark and call that negative 1. I always want it in groups of 4 and negative 2, just because it won't fit. Okay, so I know that I'm going to be starting at negative 2. And then I'm going to solve this guy. So I subtract 4 pi. I'm going to stop writing that out. So 2 pi x is equal to negative 2 pi. Divide by 2 pi on both sides, and I'm going to end at negative 1. So that means that, let's think about this for a second. That makes sense. If I start at negative 2 and end at negative 1, that means that one period, right, goes from negative 2 to negative 1, which makes sense because the period is 1. Okay, so it's just saying, hey, instead of this point being here, it's been shifted to the left all the way to negative 2. Think of like when I have a parabola, right? And then it shifts to the left, and then now it's here or whatever, right? We're doing the exact same thing. The only difference is it's going to look the same, essentially, more or less, because this repeats over and over and over again. So now I'm starting here. Okay, well, it's cosine, so my original point would be here at 1, but the amplitude is 3. So I have to start at 3. And there's an x-axis reflection, so I'm starting here at negative 3. And then I go to 0, and then it would have been negative 3, but because of that reflection, it's positive 3. And then 0, and then back to negative 3. And so this has given us our original one period of our sine wave. Sorry, cosine wave. Okay, and then can I repeat this? Yeah, you bet. Right? And it just keeps going. And I'm probably only going to draw a couple of these. But like I said, I would recommend, I always like to fill up that trig paper as much as I can. Okay, so here I just went ahead and did 4 periods. Again, I would fill it out all the way, but you definitely don't have to unless it specifically says one way or the other. Okay, let's do another one. Just lots of practice graphing here, okay? So example 6 says analyze the graph of 2 plus 3 cosine of 2x and use a graphing utility to validate your answers. So again, if you want to use a graphing calculator to check your work, you are more than welcome to do so. So we're going to make that list of all the information we know, right? So my amplitude here is 3. That's the number in front of cosine. The period for sine and cosine is always 2 pi divided by whatever in front of x, which in this case is 2. So my period is pi. So that means that fourth tick mark is going to get labeled pi instead of 2 pi. There is no phase shift here. because there is no plus or minus inside the parentheses. But now there is a vertical shift, right? It's up 2 units. Up 2 units. So now again, same thing. It's just everything's going to get moved up 2 units. Now, what makes this tricky as well is don't forget the x-axis also gets moved up, quote unquote, 2 units, right? So this is my equilibrium now. So sometimes I think it's helpful to kind of think of like, okay, now this blue line is my new equilibrium, and I'm going to graph it this way. So it's cosine, so I would start at 1, except that the amplitude is 3, so I have to start at 3, which is annoying because it doesn't fit, but that's estimated around 3, right? So that's 5 now. And then 1, 2, oh, sorry, we don't want to label it there. I'm going to label it here, 2, 3, 4. So this is now pi. So this would be pi over 2. So then I would have a point at quote unquote 0. Then I would have a point at negative quote unquote 3, right? Because this is my new equilibrium. And then 0, and then back at 3, quote unquote. So here is my cosine graph. Again, I can keep going, right? Then we'll go back to 0, and then back to negative 1, and continue on and continue on. Oops, I always do that. And so on and so forth. Again, I would get in the habit of drawing a lot of periods at once. But sometimes it specifically only asks you for 1 period, okay? All right, so hopefully that makes sense. It's the same graph, it's just been shifted up 3 units. Okay, so the last thing that we're gonna look at is how do we write the equation if we're given the graph, right? So far, we've gone the opposite way. We are given the equation, we're given the equation and then we're asked to graph it. Now we're given the graph and we're asked for the equation. So here I have the graph and it says find the amplitude, period, and phase shift for the sine function. So they already tell us it's a sine function. Okay, so that's nice. So I know it's going to be something along the lines of A times sine of bx minus c. The reason I'm not adding in a plus d, I mean, I guess we can, but I can tell just by looking at it that there's no vertical shift here. Okay, so let's start with amplitude, right? Normally my sine graph goes from -1 to 1. Here it's going from -2 to 2. So that tells me that the amplitude is 2. Also, here's my starting point for the sine graph. A normal sine graph goes up. This one goes down. So that tells me that there's also an x-axis reflection. So because of those two things, I can say that A is -2. So the A value in this equation is going to be -2. Let's just kind of fill it in as we go. So I know it's going to be -2 sine of something, right? The next thing I want to figure out is the period. So typically, right, the period is 2 pi divided by b. Okay, well, I don't know what b is, that's what I'm trying to find, but I can figure out what the period is just by looking at this. So if you think, if I go from -pi/2, and we can draw it out, right? -pi/2 is right here. If I go from -pi/2 all the way to 3 pi/2, that is 1 full rotation, that is 2 pi. So from start to finish here, I have gone 2 pi. Right? So then if I solve this, 2 pi divided by what is 2 pi? Well, that just tells me that b is 1. Okay? And then the last thing is the phase shift. I know that there's no vertical shift, but my phase shift, this has obviously been moved to the left, X number of units. So remember that phase shift is always C over B. And in this case, I know that C over B is negative pi over 2 because I've moved over negative pi over 2. Right? That's where my starting value is. So now I can solve this because I know what B is. B is 1. I just found that. So C over 1 is negative pi over 2, which just gets me C is equal to negative pi over 2. So that's the last piece of my puzzle. So now I have y equals negative 2 sine of 1x, which I can just leave, minus negative, so it becomes a plus, pi over 2. And then that vertical, there is no vertical shift here. So I don't have to write anything in for D. Okay, so this one was kind of nice because it told me that it was sine, so I knew where to start. Okay, let's look at example A here. It says find the equation that produces the graph shown in the figure below. It does not tell me whether this is sine or cosine, so I get to pick. So that's exciting. My recommendation would be look at the starting point. Look at the y-axis. Okay, that will help you determine which trig function to use. Would you still get the right answer if you used cosine here? Yeah. It would be a lot more work though. In this case, it's easier to use sine because it's already starting at 0. Right? It's already starting at 0. So that means that I will not have a phase shift. I don't have to worry about it going left or right because it's already starting at 0. So I can just start making my list. The amplitude here, normally, again, it goes from -1 to 1. In this case, it's going to 4 and -4. So my amplitude is 4. There's no x-axis reflection because it starts at 0 and it goes up, just like normal. So we can make a note of that, no x-axis reflection. So that means that my A is 4, positive 4. Okay, now let's figure out what the period is. So the period is always 2 pi divided by b. And in this case, let's look from start to finish, it goes to pi over 2. So that I know that a full period on this graph is pi over 2, and I want to solve for b. So I'm going to cross multiply. I get pi b equals 4 pi divided by pi divided by pi. B is equal to 4. That tells me what b is. There's no phase shift, right? So what that tells us is there's no, C value. And then there's no vertical shift. So that tells us that there's no D value. If you had used cosine instead of sine, you would have a phase shift, right? This would be your starting point. And you would get the right answer. It would just be a lot more complicated, okay? So now we can go ahead and write my equation. Y equals, my amplitude is 4. And we decided to use sine. And my B is also 4. And there it is. All right, you guys, that is it. We are not going to do the mathematical modeling problem on the next page. So we are done with 4-5. If you have any questions, I know this isn't easy. So if you have any questions at all, you need to make sure that you reach out to me right away. and we can go over it and whatever you need. And then I will get you some of this trig graph paper just to make your homework a little bit easier. I'll see you later.